Testing, testing, testing. Hi there, guys. My name is Rohan Beve, and today we are gonna be talking about moment of inertia. Today we're gonna be talking about, well, what is moment of inertia? So, what is moment of inertia? It's not like regular inertia, but it's kind of different. So, what is it? Its basic moment of inertia is basically like the rotational mass of an object. Okay, and that's basically what it is. So what it tells us, okay, is that basically it tells us that the more heavier, let's say here we have a boulder here that you're pushing it, the heavier, the more mass an object has, right? It's more harder to push in a line because of the mass, right? That is what moment of inertia is. Okay, so the more moment of inertia an object has, the more harder it is to spin. The less a moment of inertia that an object has, the more faster and easier it can spin. That's what moment of inertia is, okay? And it also means that it also measures it measures the resistance too around the axis of the rotation, okay? And the thing is, that's basically the main gist of moment of inertia. Okay, I'm just gonna call it MOI. That's the main thing about MOI. Okay, but it also depends on two factors. One being the mass of the object, as stated before, and two, far from the center it is. And it can all be put into the formula. This is the formula or equation for moment of inertia. Here, I is standing for moment of inertia, m for mass, and the r squared being how far from the center it is. So now let's look over some examples in real life situations. For example, you opening a door. Let's say you push near the hinges of the door, right? It's very hard. But in the outside area, right near the handle, you push it, it's more easy. Why? Because it's more farther away from the center, right? Because the thing is, how far away the force you're applying from the center is very important with moment of inertia. Okay, so it's easier to push from the handle because of that, right? It gives out more moment MOI. Okay, and the more MOI it is, it gives out more torque. Okay, which allows you to easily push the door. Now let's say, for example, there's an ice skater. Okay, there's when they're like spinning around right on the ice. Have you ever noticed them, in order to spin faster, they move their arms closer and they'd spin more? And if they put and outstretch their arms, they'd slow down, right? Why? So as I said before, here we have an ice skater, right? They move their arms in, they spin faster. They move their arms out, they spin slower. That's because, okay? So when they move closer, right, there will be less a moment of inertia, which means it will continuously move faster since there's nothing from external force, right? So in order to compensate for the angular momentum, it has to spin faster. And when you outstretch it, there will be more moment of inertia when you outstretch it more, causing the ice skater to slow down. Now let's say, for example, today here we have a bicycle wheel, okay? Now, as we see here, okay, the most of its mass is at the rim of it, okay, which is far from the center, okay. Now, it compared to a flat disk, which has the mass evenly while the mass is at the rim, okay. Because of this, the bicycle wheel has more inertia, has more MOI, because instead of being evenly distributed, let's say on a disc, right, on a wheel, right, bicycle wheel, the mass at the rims, okay, which due to, from the last example, right, the more outstretched there is, the more moment of inertia it has, and as we see, that's the same with the wheel. So there will be more moment of inertia basically means that it's harder to get it up and moving, okay? That's basically what the main gist of moment of inertia is. And that's basically it. Thank you for watching this video and hope to see you next time. Bye bye.